Welcome back to MLT 115. In today's lecture, we're going to be doing solutions calculations. In this particular lecture, we're going to be learning how to do calculations of concentrations dealing with ratios and proportions. We're also going to be learning how to do calculations that start and end with different concentrations. So before we get too far along in the lecture, let's review what a solution is. A solution is comprised of a solute dissolved in a solvent. So if you look down here at the image, we're trying to dissolve our solute into the solvent. And when you mix those together, you end up with your solution. So in calculations for concentrations, we're going to use ratio and proportions in order to solve our problems. So when we use ratio and proportions, we're going to utilize it in equivalent fractions and algebra to determine the amount of substance required to make a solution. So let's look at the example given. We've got 1/2 equals x over 4. So we're going to be trying to solve for x in this particular example. So you might have done this in a previous math class. So how are we going to solve for x? We're going to use cross multiplication, or you can use the method of cross your heart. It means the same thing, cross multiplication or cross your heart. You may have been taught either of the terminology in a previous math class or middle school. When you're setting up your cross multiplication, you can draw your arrows across or diagonal in cross multiplication so you know what you're going to multiply times each other, or you can set up as cross your heart, which will end up looking more like a little heart. Again, it's the same operation, it just depends on how you want to draw it out. But let's work over here on this one. But again, you're going to end up with the same results. So 1 times 4 is 4. 2 times x is 2x. We need to get our x by itself because we're solving for x. So we need to divide by 2. I'm just going to come over here. 4 divided by 2 is 2. So x is 2, so we have solved for x. So that's the answer to our problem. 2 equals x. Okay, in the lab world, why is this important? It's because you'll end up with basically a word problem in the different scenarios and on the certification exam, and you'll have to take that word problem and set up 2 equal ratios to form a proportion. So what's that going to look like? You're going to have to take the information that's given in the word problem, pull it out, and set it up as a ratio of being equal to each other. So it's going to look like this. And then you're going to rewrite those ratios as a fraction in order to be able to solve for whatever the unknown is. And then of course you're going to do cross multiplication just like we just did in order to solve for your unknown. Okay, let's look at an example of one of these calculations using ratio and proportion. Again, these are going to be word problems, so you're going to have to pick out the information that you need in order to set up your problem. And we need the information to set up our ratio of proportion. So let's read the word problem. Suppose a procedure calls for 400 milliliters of a 6% NaCl solution. 6% is 6 grams by way of solute, which is NaCl, in 100 milliliters. That's your total volume. So from that information given, we've got to basically pick out our 4 numbers or the 4 pieces of information that we need to set up our 2 equal ratios to form our proportion. So what's the information given? We're given 400 milliliters, and we're also given 6%, but it explains something about the 6% in this next line. It's saying 6 grams by weight of solute in 100 milliliters of the total volume. So what can we do with that? We need to set up our ratio, correct? So one ratio needs to equal another ratio. So we're going to end up with 4 values, but one of those values is going to be an unknown. So the first ratio is pretty easy because it gives us 6 grams of 100 milliliters. That'll be our first part of the ratio. And what's the equivalent part equal? Well, we know one of that's got to be the unknown. So let's read back and try to figure out what's the unknown. Suppose a procedure for 400 milliliters of 6%. So suppose, so that's the question. So that's going to be our x. And then it gives us 400 milliliters. That's what we're comparing. So now that we've got the ratio, the 2 different ratios to form our proportion, what's the next step? We can set those up like a fraction. And that's what they've done down here in this step. You've got your 6 over your 100 equals your x over your 400. Now you can perform your cross multiplication. And that's what they've done here. So 6 times 400 is 2400 equals 100x. And then we want x by itself, so we're going to divide by 100. So x is going to equal 24. And what's our units of measurement? Grams. So x equals 24 grams. Before we move on to the next example, let's talk about something first dealing with percentage. Okay, it explained what this percentage meant to us in this particular example, but sometimes it's not going to explain to us what the percentage meant or means, so we're just going to have to know what the percentage means. So for example, if we have 20% of something, what do we know that that's out of? We got to automatically know that's out of 100. So 20 can be put over 100. So sometimes it's not going to spell it out for us that 6 is going to need to be over 100. It's going to tell us, you know, maybe the percentage, and we've got to know that a percentage is from 100. The last thing I want to mention on this slide is we have this W and V that's associated with our percentage. The W represents weight and the V represents volume. So in this particular problem, the percentage was referring to weight over volume. Let's look at a second example of ratio and proportion. Again, we're going to be looking for an unknown value, but this time we're going to be looking at a volume over volume problem versus the weight over volume we just previously looked at. So again, we're going to be trying to pull 4 different values out of the information that's given. One of those values is going to be our unknown, or our x. So let's read our word problem. Let's make 50 mLs of a 0.6% serum in saline. So the information that's given is 50 mLs of 0.6%. And what I say about percentage, you just have to know it's of 100. So it wouldn't matter if it was 20%, 30%, whatever, it's of 100. So we got to take that information and use it to set up our equal ratios to form a proportion. So let's set up our proportion, our ratio proportions, and start plugging in. So what's our first ratio that we can set up? Let's look at this percentage. So if we know that it's of 100, we can go ahead and put our 0.6 is of 100. That will be our first part. And then the second part, or our second ratio, is going to have our unknown. And we're going to set up our X there, and then it's going to be of 50 mLs. So once you get your two equal ratios set up, then you can change your ratios to a fraction so you can solve it. And that's what's been done here. And then of course you can do your cross your heart or cross multiplication in order to solve. 0.6 times 50 is 30. And then 100 times x is 100x. And then of course if you want to get the x by itself, then you would divide by 100. And 30 divided by 100 is 0.3. So that's going to be your answer. X is going to be 0.3 milliliters. In this next example, we're going to be using ratio and proportion to determine concentration, or we're going to be looking for the percentage. Let's read our word problem. If a 40 milliliter ethanol is brought to 150 milliliters with water, what is the percent ethanol? We've got to use the information given in order to set up the ratio proportion. What ratio is equal to the other ratio. So let's look at what's given. We're given 40 ml is brought up to 150 total milliliters with water. And it's given, and they're wanting to know the percentage. The percentage is the unknown. In our percentage, what did we discuss is of. It's of 100. So now can we set up our equal proportions or equal ratios? Yes. So our 40 is going to go with our 150. So 40 is going to go with 150, and that's going to be equal to our unknown, our percentage of 100. So now that we have our ratios or our equal ratios set up, then we can set that up as a fraction. So we can solve. So 40 over 150 equals x over 100. And now we can do our cross multiplication. 40 times 100 and 150 times x. But let's go to the next slide to solve it all. We're performing our cross multiplication. So 40 times 100 is 4,000. And then x times 150 is 150x. And then you'll need to divide by 150 to get x by itself. And once you get the x by itself, you'll end up with 26.7 as your answer. But remember, we're looking for percentage, so we've got to have our answer expressed as a percentage. So you have to go through and divide by 100, which is going to end up with having a decimal. And then you have to move your decimal over 2 spaces to get your 26.7%. In this problem, we're trying to see if we have enough of a volume. So the x is going to be in a different location than the previous examples that we looked at. So let's read our word problem. 25 ml of a 5% NaOH are required. Only 1.32 grams of NaOH are available. Is this significant? So again, we're looking for the volume. So we're going to have to take the information that's given and set up our ratios on either side of the equal sign. When we're looking at this question, we know that our answer at least needs to be 25 milliliters at the end, because it says we need 25 milliliters, or 25 milliliters are required. So our answer, in order for it to be significant, we need at least 25 milliliters. So we're just going to hold the 25 milliliters to the side to start with. So let's look at the other information that's given. We know they give us 5%, and 5% is of 100. And they also give us 1.32 grams. They also give us the hint that this is weight over volume. So let's go ahead and start trying to set up our equal ratios. So let's start with the percentage first. So we know it's going to be 5, since it's weight, 5 grams to 100 milliliters. And what's the second half? It gives us 1.32 grams, so that's going to be 1.32 grams. And then our unknown is going to be the back half of the ratio, so it's going to be x. So now this is our two ratios set up equal to each other. So now at this point we can set them up as a fraction. So 5 over 100 equals 1.32 over x. And again, we haven't worked a problem like this where the x is on the bottom. All the other problems we've worked, the x has been on top. So let's go to the next slide to solve. You would do your cross multiplication the same way. It doesn't matter if your x is on the bottom or your x is on the top. So 5 times x would be 5x equals 1.32 times 100 would be 132, and you want your x by itself, so we're going to divide by 5. So your x is going to be 26.4, and your units is going to be milliliters. So that's going to be your answer. But what was the question it was asking? Is this going to be sufficient? And the answer is yes, it is going to be sufficient because you're going to have 26.4 milliliters available, and you need at least 25 milliliters. It said that 25 milliliters were required. On the previous examples, we've been looking at ratio and proportion word problems where the starting and the ending of the solution concentrations were the same. But sometimes in lab, you have situations where the starting and the ending concentrations are different. So we need a way to solve those type problems. And we use an equation or a formula to solve those type problems. And the formula that we use is V1 times C1 equals V2 times C2. So we're going to learn how to extract information from word problems and plug it into this formula in order to solve for an unknown. If you look at the image, the volume in the first cup is less, so the actual concentration in the first cup is higher because it's a deeper shade of blue. But the volume in the second cup is higher, or there's more volume, so the concentration is less. So you have a different volume and concentration at the beginning than you have at the end. This slide just shows the formula again that we're going to be using to solve these type problems where it changes from the beginning to end. The V1 represents the start volume and the V2 represents the ending volume. The C1 represents the starting concentration. The C2 represents the ending concentration. Let's look at an example where you would use this formula of changing from one volume in concentration to another volume in concentration. So let's read the word problem together. What volume of enzyme, 5 units per microliter, is required to make 25 microliters of a 0.1 units per microliter reaction? We have to use what information is given and pull the numbers out that we need to plug into our equation. Now, one of our numbers is going to be an unknown. So I find it easier to go in and underline the information that's given and also to label it. So what's the information they give us? They give us 5 units per microliter. They give us 25 microliters, and they give us 0.1 units per microliter. And we know something has to be our unknown. So it says what volume. So we know one of our volumes is going to be our unknown. So now we got to figure out what's our V1, what's our V2, what's our C1, what's our C2. So when we're looking back at our question, it looks like this second half of the question is what our volume and concentration is going to be changing to. So that's going to be our C2 and our V2. So when we're looking for concentration, it's usually going to be in whatever units of or percentage of. So this is going to be our C2. And our volume is going to be the 25. So this is V2. So if we know our V2 and our C2, then guess what? This up here must be our C1. Our 5 units per microliter has got to be our C1. And we already know that it's asking for volume, and we've already labeled our what volume as a volume, so that must be our V1. So that's our unknown, is our V1. So now can we plug everything into our formula? Yes. This step here is just plugging everything into our formula. Our unknown is our V1. Our C1 is our 5 units per microliter. Our V2 is our 25. Our C2 is our 0.1 units per microliter. So then we can solve our equation. I'm going to write the steps over here to the side. So we've got our V1 times our 5 equals, and you can go ahead and do your 25 times your 0.1, and that's 2.5. And we want to get our V1 by itself, so you're going to divide by 5. So our V1 is going to equal 0.5, and that will be microliters. So that will be our answer. That concludes our lecture on solutions calculations. If you need any extra help, please don't hesitate to reach out.